This is the reassessment for position, velocity, acceleration. What we have is a guy standing on the ground, and we have a train that's going up an incline with a glass door so you can see through it, going up an incline at angle theta, which is 20 degrees. And the train is moving 20 meters per second up this hill, and a ball is thrown at 3.2 meters per second inside of the train. And we want to know how fast the ball is going when it leaves the hand. How fast did this guy see the ball going when it leaves the person's hand inside the train? What we want to do is find the velocity of the ball relative to the ground. To do that, first we have to find the velocity of the ball relative to the train, which is negative 3.2, it's in the negative direction, times the cosine of the angle, because we're trying to find the x component, plus negative 3.2 times the sine of theta, which is how you find the y component, and that's how you get the velocity of the ball relative to the train. This is it. Now, velocity of the train relative to the ground in the x direction is 20 times cosine of theta, and velocity of the train to the ground in the y direction is 20 times the sine of theta. And the overall velocity of the train to the ground is 8.16 x hat plus 18.26 y hat meters per second. So to find the velocity of the ball to the ground, you do the velocity of the ball to the train plus the velocity of the train to the ground. So we get velocity of the ball to the ground equals negative 3.2 cosine theta plus 8.16 x hat plus negative 3.2 sine theta plus 18.26 y hat. And we add those together using our calculator. We get the velocity of the ball relative to the ground is 6.85 x hat plus 15.34 y hat meters per second.